All right, welcome to the 3.5 video. Our goal here for 3.5 is to verify if two functions are inverses of one another, and so there's really two goals here, and to find an inverse function. So this may break into two videos. I don't know. We'll see how it goes. So if I want to verify if two functions are inverses of one another, all right, so if my goal is to verify that two functions, so I give you an f of x, I give you a g of x, are they inverses? Well, I'm going to start off and I'm going to give you a fact. Actually, I'm going to give you two facts. The first one, it says if I plug the inverse function into the original function and simplify, then I should just get x. Also, the reverse is true. If I take the original function and plug it into the inverse function, then simplify, I should just get x. So if I take a function, plug it into another one, and reduce, the only thing that I should have left over is just simply x. So here we go. Let's try an example here. All right, the directions are going to say something like verify that the functions are inverses of each other. So here I'm going to give you an f of x equals, so 2 times x minus 2 cubed, and g, we get 4 plus the cube root of 4x all over 2. All right, so if it's true that these are inverses of each other, then I should be able to plug one into the other, reduce, and just be left with x. So let's see what happens here. There's two ways of doing this. So I'm going to do both ways. The first one I'm going to do, I'm going to take g. I'm going to take the g function and plug it into the f function. So I'm going to do f of g of x. So that means that all of this is going to go in and replace the x. So I have 2 times, now it's not x anymore, it's this 4 plus the cube root of 4x all over 2. So there's the x minus 2, and the whole thing is cubed. So let's just think about it like if you use a giant crayon and you wrote really, really big. F of x is 2 times x minus 2 to the third power, right? Well, 2 times, and if I cover this up, just think of this as x minus 2 to the third power, right? Okay, so now I need to make sense of this thing and simplify. So I'm going to do some scratch work off on the side. And I need to take a look at just the inside bit right here. 4 plus the cube root of 4x all over 2. Well, I could look at this as 4 over 2 plus the cube root of 4x over 2. So I could look at this as 4 over 2 plus cube root of 4x all over 2, like that. Well, now we know that 4 divided by 2 is 2, so that leaves me with 2 plus the cube root of 4x over 2. So I'm going to take this and replace that with it. So I have 2 times, all this becomes 2 plus, the cube root of 4x over 2 minus 2. The whole thing is cubed, right? Well, I have a positive 2 and a negative 2 inside my parentheses, right? Well, a positive 2 and a negative 2, that goes to 0. So now I'm left with 2 times the cube root of 4x over 2 cubed. And over on the side, I'm going to take a look. The cube root of 4x, if I cube it, I'm left with 4x. And if I look at the denominator 2, well, 2 cubed is 8. So this whole thing then becomes, well, my 2's here. This whole thing becomes 4x over 8. Like so. And That's because if you have a fraction raised to the third power. Let's think about it like this for a second, right? I feel like there's some issues with going from here to here. If I have something like 1/2 cubed, well, that's really saying 1/2 times 1/2 times 1/2, right? And with fractions, we multiply across the top. So that's the same thing as saying 1 to the third divided by 2 to the third, right? So when I have this fraction, I'm saying the cube root of 4x to the third, the cube root of 4x to the third, over 2 to the third, 2 to the third. Right, so I basically just did this piece by piece, just so I could see what happened to my fraction. Well, now this isn't too terrible, right? I can now, so look at this, is like 2 over 1 times 4x over 8, and 2 times 4 is 8, so I have an 8x, and 1 times 8 is 8, 8x over 8. Well, the 8's cancel, and I'm left with x. So, are these inverses of each other? Well, that's a big resounding yes. All right. Now, let's try another one. Let's go with one more here. And if you want to prove it to yourself, try taking f of x, this whole thing, and replacing the x with it. If you take this f of x and replace x and go step by step. Now notice how it takes me some time. I go step by step, simplify one thing at a time, use your scratch work, go one step at a time, and I think you'll find that you will surprise yourself with your ability to simplify some of these. All right, let's take a look at another example. What if we have something like f of x equals negative 4/7 x minus 16 over 7. And we get a g of x that's like 3/2 x minus 3/2. Okay. Well, last time I took the g and plugged it into f, so just for grins, I'm going to take the f and plug it in for g. So that means I'm going to take this whole thing and plug it in just for x. So g is the outside, f is the inside. So I get 3/2 x minus 3/2. And what's going in here is all of that. So I get negative 4/7 x minus 16/7. Okay, so now we want to simplify. And so here I'm going to distribute. I'm going to distribute 3/2 to both. And so over here on my scratch work, I need to know 3/2 times negative 4/7. And 3 times negative 4. 3 times negative 4 is negative 12. 2 times 7 is 14. All right, so then I get negative 12 over 14x. And now I have to send 3/2 to negative 16 over 7. So 3/2 times, or I can make a positive 16 over 7. And just make that a minus. So 3 times 16, so 48. 48 over 2 times 7 is 14. So I get 48 over 14. And then my minus 3/2 goes here, right? Okay, now I need to make sense out of negative 48 over 14 minus 3/2. Now we're adding and subtracting, right? So when you add and subtract, you have to have a common denominator. Well, my common denominator between 14 and 2 is clearly going to be 14, so I get negative 48 over 14 minus something over 14. 2 to 14, I have to multiply by 7, so 3 times 7 is 21. Negative 48 minus 21 is a negative 69. Is that right? Yep. Over 14. So then g of f of x is negative 12 over 14x minus 69 over 14. Nothing else I could do with this here. So since this did not go all the way down to just an x, then f of x and g of x are not inverses of each other. So my answer with this would be no, they are not inverses of each other. I'm going to do the rest on part B. So this is the first half of 3.5, and the rest is going to go in on part B.